Hello, good evening. ಹೇಗಿದ್ರಲ್ಲ ಎಲ್ಲರೂ? This is your captain Shreyas on the Vedantu Karnataka, Namma Karnataka channel, and we are reaching almost the end of the ray optics lecture. And today we are going to discuss prisms and dispersion, a small topic, but you will see most of the times in KCET, in PU, or even in Comed K, they will ask you so many questions. All right. So let's begin with this chapter with your captain Shreyas. I hope I'm audible and visible to all of you. Right? Ready for it? Awesome, awesome. Let's go. So, in this particular part of prism, let me start off with what exactly do you mean by a prism? See, prism is an optical device. Prism is basically an optical device with two inclined refracting surfaces. With two inclined refracting surfaces. Examples could be examples. I can give you so many examples, my dear students. Like, say, this one. This one, or let's say this one, or let's say this one. Basically, all these are prisms as long as you have two refracting surfaces, meaning that if at all, let's say light will enter from here, this is the first surface where it will refract, and this is the second surface where it will refract, so it will refract two times. If light entered here, maybe it will refract like this, and maybe, who knows, it will refract like this. Then similarly, if light enters here, maybe it refracts here and then refracts here. So all these things are basically prisms where you have two surfaces at an angle, and at both the surfaces the refraction happens. I hope, yes, everybody has understood this point. Hi Kushmohit, Meghna, welcome aboard. Nice to see all of you back over here. Yes, all right. Now, there is a particular angle of importance which you should know, and that is basically this angle. And over here, that angle is not so evident, so I might have to extend those refracting surfaces like this so that I am able to figure out what that particular angle actually is. So this particular angle A is called as the refracting angle of the prism. Refracting angle of the prism, or sometimes just called as the prism's angle, or just the prism's angle, right? So whatever you want to call it. So that is basically your A. So we can see how the refraction occurs in a prism in this very simple simulation. By the way, I hope you have subscribed to the channel, and if you have not yet done that, please do that right away. And if you have not yet liked the video, smash the like button right away, right now. And also you will get all the notes here in the Telegram channel. Yes, make sure you are a part of that particular Telegram channel. Okay. So as you can see over here, this is a torch. I can turn on the torch and the light is going straight. If I put a prism in its path, you can see it is bending the light. The light is getting refracted here and here two times. I can change the angle of the prism, and you can see it will deviate, it will bend by different amounts. I can also use this as a prism. This is also a prism, as you can see, because it has two refracting surfaces making certain angle. But this is definitely not a prism because both the surfaces are parallel to each other. So you will see the ray will go parallel to the manner in which it was incident. So this is not a prism. This and this are prisms. Why is this not a prism? Because the sides are parallel, they are not inclined. And if you notice, I've clearly mentioned the word inclined refracting surfaces. Is that clear, everyone? With me on this? Very good. Awesomeness. Now, there are some geometrical nomenclatures terms which you should know about a prism. So let's start doing that first. Imagine this is your prism. Okay, this is the angle of the prism. All right. Then what happens is light, let's say, will enter here. Then it goes, let's say, like this, and then let's say it goes like this. So the path taken by light is like this. This light is basically called as the incident light. This is your incident light ray. It is refracting 2 times, and this is then the emergent, it emerges out, so emergent light ray. If I draw now the normals at both the places over here to figure out the different angles involved, it will look something like this, I believe. Oops. Like this, okay. Now these angles also have some names. This is your incident angle, this is your emergent angle. These internal angles here and here, that is R1 and R2. That is basically your R1 as well as R2. That's the first thing that you should know. Next important thing, I can use Snell's law at both the surfaces. So using Snell's law at both the surfaces, here is what I can get. First of all, over here, this sin I by sin R, if the prism has a refractive index of mu, I can relate this particular mu as sine of incident angle by sine of R1. That is one way. But over here, don't write this as the incident angle because this is inside the denser medium. So sin I by sin R, rare by dense. So here also I should go rare by dense. So that's why it should be sine of emergent angle by sine of R2. This is in the denser, this is in the rarer medium. I hope this distinction is clear. I'm so glad, Meghna, your marks are increasing. And for the first PU, how to get good score channel, well, I will tell you. Basically, first PU, the topics might seem very intimidating because very new, very difficult things might involve you, like mathematics might be a little bit crazy. So mainly make your mathematics strong, number one. The basics of all the subjects should be clear, like the mole concept, the vectors, the kinematics, or whatever, the first few chapters of mathematics. Once you understand it completely, then you will be able to understand the remaining topics, and it is very logical and it is sequential. You cannot skip any chapter and go to the next chapter. That is the reason why sometimes first PU can be difficult. It's okay when if you have backlogs, but you have 3 months of time. Dedicatedly devote 2-3 days in a week for just backlog completion. Meanwhile, you can continue with your current syllabus which is going on in your PU. Okay, I hope this is clear. Hi Prabhu. Yep. All right. So that is the first thing which I have written down over here. So might as well block this particular part. Now, the next important thing that you will see over here, which you will get, is that if you look at this particular triangle which I am going to show you now, this triangle which I am going to highlight for all of you, this one. Look at that triangle. In the triangle which is marked, the sum of all angles must be 180 degrees, which definitely then means this angle over here, because this is R1, so the remaining angle must be nothing but, how much will this be? How much will this be? This will be 90 minus R1. And even this particular angle that you see over here, this should be 90 minus R2. If you are wondering why that 90 came, think carefully. This angle is 90 degree, even this is normal, so this is also 90 degree. So the interior angles are 90 minus R1 and 90 minus R2. So what you will see is 90 minus R1 plus, this is the first angle, 90 minus R2 is the second angle, plus the angle of prism A is equal to 180 degrees. Best part, 90 plus 90. Can you see over here what is happening? 90 plus 90 is 180 degrees. I can shift that R1 and R2 on the other side, R1 plus R2. And over here on the left hand side, I'll be left with A, and this on the right hand side is 180 degrees. Yes, I've just shifted R1 and R2 to the right hand side and kept A with this 90 plus 90, which is 180 over here. 180 and 180 will cancel. So what will I get? The angle of prism is nothing but R1 plus R2. Perfect. So this is another result which you should remember. The angle of prism is the two interior angles when it is refracted. Cool? Awesome. For preparation of preparatory exams. Wow, this is interesting. Preparation of preparatory exam. Definitely, I will do that. But I'll tell you, Prabhu, one thing. Please follow the KCET classes. It will help you a lot in your preparatory exams. Don't be worried so much about the preparatory exams. Even if you do bad, and often the papers are set really hard deliberately, your actual marks usually increase. Number one. Number two, your KCET marks also count when you decide on a college, because COMEDK you have to pay higher fees. Number three, you don't get too much time also to prepare for KCET after the PU examination. So simultaneously prepare for PU and KCET, especially the 12th standard. And anyways, the weightage of 12th standard is also higher. These are my main tips is what I would say. Other than that, obviously, write all the questions which have been asked in the examination. Write, not read, write at least once, even if you don't understand them. Trust me, in the actual exam, it will help you. Okay, next important thing. Sir, this angle is done. Now, what is the next thing that, sir, you will show us? See, the original ray actually wanted to travel over here, but it ended up going here. So you can see it has been deflected by some angle over here. So definitely now I have this particular angle, which is delta, which is the deviation angle or the angle of deviation. Deviation angle, which is basically your delta. Now, this particular delta that you see, can be found out in the following manner. This net deviation is basically of deviations, the sum of deviations at both the surfaces, refracting. So you will have addition of two terms, deviation at the first surface plus the deviation at the second surface. Now you might be wondering, what is the deviation on the first surface? There is a formula for refraction whenever incident angle and refracting angle are given. So some of you might have forgotten it, so I might probably have to remind you of that. Say for example, you have this surface, let's say this is the normal, let's say this is the light which is entering, this is the light which is getting refracted. So if you see, the light wanted to go over here like this, so this is the deviation produced. If you notice, this is the incident angle, this over here is the refracted angle. Now if this is I, obviously even this whole angle is also I. So what will this delta be? This deviation angle will be this total angle minus this R. So I minus R. But sometimes R is more, I is less. So that's why we put bigger minus smaller. So you put a mod symbol. Why is this mod put? Because I don't know who is more, who is less. It depends on dense, rare, medium. That's why I minus R modulus. So over here, as you can see, it should be nothing but I is bigger, R1 is smaller. That's the first deviation. Here E is more, R2 is less. So E minus R2. That's it. So that will basically give you delta. Now this delta further can be written down as, see this R1 and R2. R1 plus R2 is nothing but A. I just have seen that before. So therefore, I can just write this as I plus E minus R1 plus R2, but I can further write this down as I plus E, that is your delta. And what is R1 plus R2? R1 plus R2 is nothing but A. This thing is nothing but the angle of prism. That is what I had proved it right over here. So hence you will see this is the deviation formula. Hence you will see this is nothing but your deviation formula. Is this absolutely clear? Yep. No, this is not lateral shift. This is deviation. Lateral means it will just shift like this without turning. Here it has turned, so that is called as deviation. Okay, fine sir, I understood it now. So can you see that deviation depends on incident angle, angle of prism, etc. All these things will obviously depend on the refractive index. And now comes a very interesting part. So say for example, you were interested in how much deviation is produced and you want to draw it graphically, and you want to draw it graphically, and on the y-axis you have the deviation, on the x-axis you have the incident angle. Okay, now how will this particular graph exactly look like? So let's do it experimentally. Let's get rid of this guy, let's also get rid of this guy. So what I will do, I will just turn the prism and you see how it is deviating the light. As you can see, it has deviated till here. Let me use a protractor so that you guys can see right over here. Okay, something like this. I'm just chumma keeping the protractor here, and I'll put it over here. As you can see, it has deviated here. I hope you can see there is a marking like 0. Now if I rotate this, as you can see, the deviation has reduced. It is not deviating so much. And then finally, it again starts increasing, isn't it? Everyone, observe this very, very carefully. What is happening? Here the deviation was good enough. Forget this protractor if you don't want it. Let us just get rid of it. It was deviating a lot. Okay, it was deviating here by this much amount. Now if I change the angle of the prism orientation, you can see the deviation has reduced, and now again it starts becoming maximum. So there is a point when the deviation is minimum. You see that this one, nothing can go less than this. I mean these two sizes are involved. You can see always the deviation is more than this minimum deviation. So the graph also looks somewhat like that only. You will see the graph looks somewhat like this. As you increase the angle of incidence, the deviation will reduce till it reaches a certain minimum value, till it reaches basically certain minimum value right over here. Okay, so this is basically your delta minimum. And like you can see, when the deviation is minimum, now I think yes, after this the deviation increases. You can see it is increasing. Before this it was decreasing. So this is when the deviation is minimum. The ray inside is parallel to the base. This angle will be equal to the emergent angle, incident equal to emergent. Internal angles are equal. Everything on the left side is equal to the everything on the right hand side. Basically it is completely symmetric, which means the incident angle is equal to emergent angle. R1 is equal to R2. Yes, and the ray inside is parallel to the base. The ray which is inside is parallel to the base. That's when the minimum deviation occurs. Now by using formulas, you can easily figure out what is the relationship, and the relationship comes out as mu is equal to, observe carefully, sine of A plus sine of A by 2 over here. This is your angle of prism, this is your angle of prism, and here you have that minimum deviation, delta minimum. This is the formula relating refractive index, angle of prism, and the minimum deviation. Usually you will know mu, A will be also given. From this you can find delta minimum, or you can also do opposite as well. This is how you solve the problem. Okay. For lateral shift, deviation is 0. Yes, Zahid Beg, correct. Meghna, if you get confused seeing question paper, that means you have to develop enough confidence for practicing questions. Number 1. Writing is more important. Number 3. Revision is more important. Number 4. Solve many small mock tests as much as possible before the actual test. That is what will help you. Is that okay? Fine. Namaskara, Rohan. Yes, namaskara, namaskara. Okay, so I hope this is absolutely clear, my dear students. So let me just also block this particular result. Okay, sir, fine. Now, once we have blocked this, there is a special criteria which is also given in your textbooks. So probably I will have to redraw this entire diagram, because they have told that what if you have a very thin, what if you have a very thin prism? When this angle is small, such a prism is called as a thin prism. Such a prism is called as a thin prism. Okay. And in such a prism, when that light will enter, will refract and emerge out, again this is deviation. If you plot this graph, first of all, the deviation is very small. It's not big. See, here the deviation is significant, right? But here the deviation is small. Not just that, it is roughly a constant. So it is not going to change much. It is probably going to look like this. So delta is small and approximately same throughout. That is the shift. So even if you show this minimum deviation or any other deviation, almost all the values are going to be the same. Almost all the values are going to be the same, no matter what angle of incidence you choose. So this is when I will be equal to E. That's when you will get delta minimum. So delta in general is still approximately, no matter whether you choose this or this, it's the same, approximately it's the same, is same as delta minimum. And this delta minimum comes out as the angle of the prism into mu, which is refractive index, minus 1. Angle of the prism into mu minus 1. This is another very crucial and important result. Crucial and important result. Yes, definitely, Rohan. I have already taken that into account. Yep, we'll definitely tell you about how to prepare for the preparatory exams as well. The last point in prisms, is, say, this is your prism and you have white colored light. You have basically white light falling onto it. What do you think will happen? Let's have a look at it by actually making white light fall onto this. See this. It's a beautiful thing which is happening. That white light is slowly spreading out like a rainbow. Are you able to see that, my dear warriors? Can you see that rainbow right over here? Maybe I can move it here. You can see a rainbow. Can you tell me, looking at this, I can also change the refractive index. Environment is air, okay. The object is glass, I can make it even more highly refractive. Who got most deviated? Tell me quickly in the chat box. Who was the one who was most deviated? Was it red, yellow, green, blue, or violet? As you can see, the violet is the most below one, so it is highly deviated, whereas red is deviated the least. So that means the refractive indices of red, yellow, etc. are also going to be different. So what you will notice is that the red color will probably be here, probably go like this. Then you will have obviously orange color and so on and so forth. Then you will have the average color, which is also yellow. The average of white is yellow. Something like this, trying to be as accurate as possible. And the last color, violet. Something like that. This phenomena of splitting up of light is called as dispersion. So dispersion is nothing but dispersion. Dispersion. What is dispersion? It is splitting of light. It is basically the splitting of the light into its constituent colors. Due to difference in refractive index. Due to difference in the refractive indices. Actually, white is not a pure color. When all these rainbow colors fall on your eye, your brain perceives it as white. So white is not a pure color like violet, yellow, orange, or red, or green. Even maroon is not an actual color. It is just a combination of few colors. So when you split a perceived color into its original components, like you take a vector and split it into x, y components, same way, that phenomena is called dispersion. Now why does that happen? Because red, yellow, basically all these wavelengths, all these colors have different refractive indices. So as you can see over here, red deviates the least and has the least refractive index among all the colors. Whereas if you see, violet deviates the most and has the highest refractive index. Also, one important thing, if you take the refractive index of violet color and you take the refractive index of red color and you take the average of them, any guesses what you will get? The average of the two extreme colors, red and violet, what you get is basically the refractive index of the yellow color. Yes, it is the mean. Yellow is basically the mean or the average color. Very, very important. A lot of phenomena are also based on this. Example, rainbow. The rainbow phenomena is based on this. Or even in your camera lens, this happens. And sometimes you might not see distortion. Chromatic distortion happens because of this dispersion. Imagine some person is wearing colorful dress, When it enters the camera lens, each color will go in a different way because of dispersion phenomena. So you might not get a very clear image. So this phenomena again of dispersion affects the camera lenses, so they have to correct it also. So there are many more applications of dispersion, all right, to study the composition of colors, to study the composition of the light, what is it made up of, etc. So these are some of the applications of basically dispersion and prism phenomena. Till this point absolutely clear? Okay, cool. So with this, I think we can start with some questions based on prisms. Let's start with some basic questions first. If the incident angle is 20 degrees and the deviation produced is 50 degrees for an equilateral prism, find the emergent angle. You have to find what the emergent angle is going to be. I delta and equilateral prism. Equilateral prism means angle of prism is 60 degree, and we all know the formula delta is I plus emergent angle minus A. Therefore, E will be delta, take that I on this side, A will become plus A. What is the deviation? It is basically 50 degrees. What is incident angle? It is basically 20 degrees. What is the angle of prism? Equilateral means 60 degrees. Okay. 50 minus 20, 30. 30 plus 60, 90. So the emergent angle is basically 90 degrees. Close enough to 90 degrees, almost like grazing that surface and coming out. That is what the answer to this particular question will be. Next question coming up on your screen. Here it is. For a thin prism of 6 degrees and refractive index 1.5, find the deviation produced by it. Find what kind of deviation is produced by it. Because it's a thin prism, the deviation approximately for all the angles is same, and it is A into mu minus 1, which is the formula which I just provided you right over here. So just use that and you will get the answer. Angle of prism 6 degree, refractive index 1.5 minus 1. So 6 degree into 1.5 minus 1 is 0.5. So it will be just 3 degree. So the deviation is just going to be 3 degrees. Cool. Let's go to the next question coming up on your screen. All right. If the red color's refractive index is 1.52, is 1.48, violet color's refractive index is 1.52, and angle of prism is basically 10 degrees. Can you find the angle of dispersion, which is the angle between the red and the violet colors? That is the question. How do you solve this particular question? Let's try to figure this out. But before that, let me bring this diagram back over here, because that might be needed. Question is to find what is the angle of dispersion between them. I don't need all these things. Let me just get rid of it. The angle between, what is dispersion angle? Angle between red and the violet rays. So what I want is basically this particular angle. I want basically this particular angle. Let's say I call it theta. Let's say I call it theta. How do I find theta? Think about it. I have an idea. I have a brilliant idea. See, I know the incident light is going like this. If red light extended backwards, it will meet over here. Violet light extended backwards, it will probably go over here. See, red has bent by this much. This is deviation of red. Similarly, the violet color has bent by this much. That is deviation of violet. So this much is the deviation of violet. This much is deviation of red. From violet, if you take away red's deviation, what is left? Theta, right? That's it. So basically, that theta will be nothing but from the violet's deviation, take away the red light's deviation. That's it. That is what will give me theta. My job is done. So very easily I can now solve the problem. So let me write theta will be nothing but deviation of the violet color minus deviation of the red color. What is the deviation of the violet color? Angle of prism into mu y minus 1. What is deviation of the red color? Angle of prism into mu of red minus 1. As you can see, A and A will just get cancelled. I hope you are able to see that. And if you are not able to see that, no issues. This is A into mu y minus A. And over here, we have minus A into mu r, minus minus becomes plus. So this is plus A. As you can easily notice, this A and this A will get cancelled out over here. And what I am left with is A into mu y minus mu red. Substitute angle of prism as 10 degrees. Refractive index of violet is 1.52. Refractive index of red is 1.48. So that is 10 degrees multiplied by, this is going to be 0.04. Therefore, our theta will be, when you multiply by 10, it will be 0.4 degrees. So the spread angle will be 0.4 degrees. It's a very small angle, which is okay. That's how you solve this question. Let's go to the one of the last questions coming up on your screen. Okay, and here it is. Imagine there is a question like this, and it says the angle of prism is 60 degrees. Refractive index is √2. Question is find delta minimum, angle of incidence, and the angle of emergence. All these things. So refractive index is given and angle of prism is given, and you have to find incident angle, emergent angle, refractive index is already given, so deviation angle, everything. I remember there was a formula which related refractive index and minimum deviation. Maybe I'll have to start with that. So mu is equal to sine of A plus delta minimum by 2, whole thing divided by sine of A by 2, if you remember this correctly. This was the formula. Oh, okay. So mu is basically √2 multiplied by sine of A by 2, I have shifted it there. So sine of 60 degrees by 2 is equal to sine of A, which is 60, plus delta minimum, the whole thing divided by 2. So this is √2. What is sine 60 by 2? Sine 60 by 2 means sine 30. Sine 30 is basically half, is basically sine of 30 degrees plus delta minimum by 2. √2 into half will become 1 by √2 is nothing but sine of 30 degrees plus delta minimum by 2. Whose sine is 1 by √2? Obviously 45 degrees. So this whole internal angle, therefore what it means is that internal angle 30 plus delta minimum by 2 is 45 degrees. Therefore delta minimum by 2 is 45 minus 30 degrees, which is 15 degrees. So therefore delta minimum is 2 into 15, which is nothing but 30 degrees. So we have found delta minimum. Once we find delta minimum, the rest of the things are easy. Remember, delta was I plus E minus A, but delta minimum will be I plus emergent angle is also I minus A. Remember, that is the theory which I gave you when I taught you this. Incident angle and emergent angle both are equal. So that is only true for minimum deviation. Oh, so do I know the minimum deviation? Yes, it is 30 degrees is equal to I plus I means 2I. Angle of the prism, it is 60 degree. Okay, so therefore 2i will be nothing but 30 plus 60, which is 90 degree. Therefore incident angle is 45 degree. But remember, I is equal to E, so it will be both equal to 45 degrees. So we have got that answer as well. That's how you solve these questions. So I hope I have made you practice enough questions, and I hope you have got some confidence on how to answer and approach a question based on prism and dispersion, and also understood the optics behind the prism, the deviation, the dispersion, and how the graphs are, and thin prism, and everything about it. All right. So that's it for today, my dear warriors. I hope you enjoyed this topic and also enjoyed the simulations. I want to know from all of you in the polls which are running on the channel right now, what do you guys prefer? Do you want one shot long marathons like, sir, you took ray optics in 4 classes, but instead can you do it in 1 class or maybe 2 class, but you don't take 1 hour class or 45 minutes class, take a 3-hour class? Or do you want topic wise small sessions like we are doing right now? Okay, what do you prefer? Just let me know over here. Just putting it over here, I can see some 65% students are saying one shot long marathon. It's up to you what you want to what do you think is better for you in this coming few days, so that we complete maximum syllabus in the coming month. Okay, I want to know from all of you. All right, thank you for liking the video and thank you for subscribing. Bye bye, take care. Captain Shreyas signing off.